Okay, so since we are going to learn how to measure the internal resistance, the first thing you're gonna have to do is make connections with the ammeter, okay? And also you have to know there are two potentiometers. I don't know about their specification, but I guess you can just figure it out later on. I mean, by measuring with the help of a multimeter. So how you can do that, I will obviously let you know. So what I did was, so when you open the package for this one, you are going to find like screws, then washers like this, and then also something just like this one. Okay, so what I did was, first I have the screw, then I place this metallic thing where I can attach my screw to, and then I have the washer, and then I just tighten it over here. So I just did this so that I don't have to make connections separately. That's the first thing I did. Secondly, I'm gonna start constructing this now. So see, for the ammeter, what's happening is, if you hold it towards you, on the right side you're gonna find the positive terminal, and on the left side it's the negative terminal, because when you turn it over, the positive and the negative terminals are clearly specified. Okay, what I just did was to construct a circuit. Like you can see, I just use 100 kilo ohms of resistor, and then later on I'm going to be supplying the power over here, but I still haven't connected any potentiometer, and now I will supply the power to the Labrador. Now I just supplied 4.5 volt. The reason is because you can see in the manual it's mentioned that we are going to use 100 microampere ammeter, right? But our one is 50 microampere. So what I did was, like they say that we have to in the PSU unit on the right top in the right hand side of the screen, where you can adjust the power supply, there you can just like adjust the power knobs. But for us, what is happening is, in order to get 50 microampere of current, like 4.5 over 100k, around 45 microampere, but we actually get a bit more of voltage. That's why we, with 4.5 voltage supplied, we already get the deflection at the maximum point, which is 100 microampere. The next thing is, we have to connect the potentiometer across this ammeter, right? So as you can see, if I hold it, so there are 3 pins. So the middle pin is the separate one, and you can use any of these 2 pins and the middle pin. So this is one end of the terminal for the potentiometer, and either one of these 2 you can just use it. So I'm just going to use one of these, and then this one. Now, like I was saying, this one is a separate end of the potentiometer, and you can use either one of these 2. So you have to connect it in a way so that they don't get short. Okay, so if I just hold it like this and turn it around, that's how I'm going to place it on the breadboard. Okay, now this is coming out of one end, which is the middle end. This is coming out of the second end, right, which is the ground one. So let me take a big wire for the ground. So this is the ground one. Ground one is going on the right side, just like this, as you can see, and this wire is coming out of the middle one. So what I'm doing is making the circuit diagram. Now while you do this, make sure this thing is not connected. So I tried doing so, but you have to make sure that it's not connected, suggested by the manual. Now what's the value of this potentiometer and how you are going to adjust it? So you see, if you put it on the breadboard, then there is a plus sign on top of it. So if you have a screw like something, that you have to turn it around, turn the knobs to adjust the resistance, to vary the resistance. And when you reach a certain point, then the deflection at the 50 microampere would reach to 25 microampere, which is the half of this meter. So when it does that, the resistance at which it does so, you will have to note this one down. Okay, So make sure when you do that, you take the reading of that. So now you can say like how you can, you know, simultaneously measure this one and this one with the help of that, whatever. So what I'm doing is, like, I have two additional wires coming out of these two terminals. As you can see, I just bended this one a bit. What I did was, I have my multimeter. I have this one set. I have this one set. And then what I have to do is just I have to turn the knob around. Okay. So I set it to 20K. And then I will have to turn it around. After that, you have to connect the power. Okay. Now you are seeing it is giving me 0 microampere, right? The reason is I still haven't started turning my knob around, but when I keep doing so, it's going to reach at halfway through at a certain value of this potentiometer. And when it does that, you will have to note down the value of the resistance that it's giving. So this is for something for you guys to find out. So I already did that. I already know the value at 4.5 volt. What should be the value of this resistor? So I'm just going to skip that part out. You have to find it out by yourself as you are going to be writing the lab report. Okay, so if you recall, like I connected the potentiometer in parallel with the ammeter, right? The reason is because the resistance is adjusted to produce the half scale reading on the meter. I guess that's what you noticed, right? The reason is because only half of the original current flows through the meter and the other half flows through the potentiometer. And what do I mean by that? You are going to figure out like through this circuit that I have over here. So in the second step, what you have to do is you have to construct the ammeter by yourself. So if you see this figure 2, then on the right hand side you are gonna see constructed ammeter portion, and what it does is like it's going to show, like I said, on the meter you on the ammeter you are going to see only half the current that I'm supplying, right? So see, I just constructed the circuit over here, and what I did was, so if you take a look at the bottom, like, you know, the table 1 of the ammeter circuit, you are gonna see scale deflection that writes full, then 3/4, then half, then 1/4, right? So what I'm going to do is adjust the voltage so that this deflection gets to the 50 microampere. So you are going to see whatever, so the milliampere meter that I connected with the help of multimeter, that actually shows you the original current of the circuit. And what you are seeing over here, this is exactly half the current that you are trying to see over here. So if you measured the resistance correctly in the last step, and if you connect a potentiometer just like the instruction suggests you to, then you will be able to get the total value of the current over here. And if you have half the value over here, that means you have successfully constructed the ammeter. And what do I mean by that? You're going to see it in the next step. All right, so in the last step you have seen that I have connected the potentiometer in parallel with the ammeter over here, right? And that is because the resistance is adjusted in a way so that we can have at exactly half scale reading on the meter. And how does that interpret? It said that only half of the original current flows through the meter and the other half flows through the potentiometer. Okay, so what happened is that's what we did in the first step, which is a measurement of the internal resistance of the ammeter, right? And then now we are going to construct the ammeter circuit, and that's what I did over here. So when I constructed the circuit over here, that's what I did. Now according to the manual, like if you remember, like they said that we have to they talk about an ammeter where the full scale deflection means 100 microampere, ampere, right? But the ammeter that we have, it actually reads to 50 microampere, right? That's what I wrote over here. So what has to be done in second step of the ammeter construction, which is figure number 2, you are going to see that they have said to adjust the value of the potentiometer to 1500 ohms, which is 1.5k, and minus the value of the internal resistance of the ammeter that you got in the first step. But since our ammeter gives only 50 microampere as full deflection, our case the equation would be different, which is 3000 minus the internal resistance of the internal resistance of this ammeter that I have over here. And when I supply the voltage, then if I see this ammeter current is half the current of this one, then that way you can verify that the ammeter has been constructed, because half of the current is going through this and rest are going to the potentiometer like they said. Okay, so that's what I'm going to do, which is there's nothing actually in this video to show on the screen. That's why I'm over here hands-on. So I'm just connecting the power supply, and you can see the ammeter deflected to around 38 or 37.5, right? And over here you can see it's 75, which is twice the value of this one. This is actually verified. Now if you see the table 1 of ammeter circuit, then they actually tell you to calculate the percentage error for full deflection, for 3/4, for half deflection, and 1/4. So actually I haven't been able to get 1/4 because when I adjust the power supply unit, so now it's at 3/4. Like see, I'm just adjusting it, oh, and then it goes back. So I have to be very careful like where I'm going with the full reading over here. Okay, this is something that you might face, so you have to be very careful about this. So what I did was I again disconnected this and then reconnected it to the PC and reduce the power supply unit's voltage. Okay, it was around 9 volt. So since I'm seeing that the circuit is being disconnected, so the Labrador is being disconnected from the circuit. So what I'm going to do is I'm just going to take 3/4 of the reading, which is over here, and you can see at 38 you are getting around, for 38 microampere over here you are getting 79, which is twice the this reading is half the value of this one. So I'm just gonna do the same for the half deflection. Okay, so if I try to reduce the supplied voltage, then I reach at 25 microampere. So 25 or 26, as in like around 54, which is totally okay. And I try to reduce it further, but it doesn't reduce because it supplies voltage from 4.5 to 12 volt, right? At 10 volt the circuit is getting disconnected. So I just didn't want to mess with it. If you can take it to the full deflection by adjusting the voltage from the power supply unit, then just put it there. But if not, then I would be happy with the half scale deflection and 3/4 of the deflection. You have to put the values in the table, and then what's going to happen is you have to calculate the percentage error, right? So you can see the milliampere reading is the reading of this one, and the microampere reading is the reading of this one. So microampere reading, when you try to put the value, you put the value as 2 times this one. Okay, and when you do so, then if you calculate the percentage error, it's gonna be very, very, very little. So those, if you have the values for those two deflections, which is half the deflection over here and 3/4 of the deflection, then I guess you would be okay for the lab report. And after this we are going to go over to the voltmeter circuit. Now I did the voltmeter construction circuit setup as per the manual suggested, and after it does so, then you are going to supply 10 volt using power supply unit on the screen, right? So I supplied that. You can see 50 microampere of current. That's not an issue over here. The thing is what value we are getting. So 4.88, that is our constructed voltmeter value. And the next step is I am going to disconnect the right hand side circuit, which is the constructed voltmeter circuit, and then measure the voltmeter reading. And after that, whatever the voltage comes, that would be my constructed circuit. So I am going to write those values in the table 2 of figure under figure 3 table. Okay, now I disconnected my right hand side circuit of the figure 3, which is the constructed voltmeter circuit, and you can see the voltage actually rose from 4.88 to 4.95. So this 4.95 is my unloaded voltage. All right, so sorry, I have just constructed figure 4. As you can see, in the figure 3 there were no potentiometer, and now I have one, because the value of this has to be adjusted to 1/9 of the value of the internal resistance of this ammeter that we calculated in the first step. So that's what I did. I constructed the figure 4, and then I am going to connect the Labrador and supply the power, which is 10 volt. And after I do so, you are seeing that I have 4.45 as the constructed voltage measurement, right? And then I will calculate the unloaded value. Now I just disconnected 10k resistor of the constructed voltmeter from the circuit which is on the left, and then I am getting 4.5 volt. This is my unloaded value. Okay, and then I am going to go forward to the next figure, which is figure 5. Okay, so the next step is ohmmeter construction. So over here, this RX stands for the potentiometer, right? And I tried setting this circuit, but it was kind of like confusing for me. So what I just did was I have the potentiometer set over here. I have the digital multimeter then connected over here, and then also the 5 kilo ohms, right? So potentiometer 5 kilo ohms, and then I connected one end of the digital multimeter over here, another one over here, and my digital multimeter probe was pointing towards 200 milliamps. Okay, so you can set it to 20 milliamps, because 1 milliamp is the maximum current that we are going to read. So set it set the potentiometer, turn the knob in a way so that the value reads just like this table. As you can see, it's from 0.1 to 1 milliampere. But what I'm just going to do is ask you guys to do is like just calculate the resistance across the potentiometer when the current flowing is 0.1 milliamps, 0.5 milliamps, and 1 milliamps. So this way your ohmmeter construction would be complete. You have all the readings, and thus we are done with today's lab. And now I'm going to move over to the question answer session.